welcome to my channel. So in this video there are two goals. The first goal is to see how we are going to solve this problem, then we are going to do some coding work. The second goal is to see how we should behave in a real interview. So let's get started. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel because it can help me to grow. So thanks a lot. So in the real interview, the first step is always try to understand the question. If there is anything unclear, please ask the question to the interviewer, and also at the same time think about some edge cases. So let's go through this question. So given an array of the positive integers array, return the lexical graphically largest permutation that is smaller than array that can be made with exactly one swap. Okay, so if it cannot be done, then we just return the same array. So I think it's pretty clear. Let's see some constraints. So the constraint says that the array is never going to be empty. So each number is between 1 to 10k. That's a pretty good constraints. So if there is some restriction, if there is some edge case, I think the only edge case I can think about is what if the input array only has one number. Then if it has one number, we just directly return the array itself without doing anything. Other than that, I think not too much room to think about edge case. But I think that edge case can also be covered by our general algorithm as well. So the next step is for us to think about the solution, how to solve this problem. And at the same time, we will do some runtime space analysis to see how efficient the approach is. So let's see how to solve this problem. So I would say it seems like what we could do is we could go do one pass through the array from the end to the start. So from the end, let's take the example in example 3 to see how it works. So you start from the end towards the beginning. So if it is in the decreasing order, non-ascending order, so if it is in decreasing order, then it is fine. So if the decreasing order just break, so let's say from 7 to 6 to 4, everything works well. But when we encounter the 9, so that's the thing. That's the thing that break the descending order. So what we are going to do is we are going to try to find everything that comes after 9 that is smaller than 9, but it is the largest within within the suffix. So among all the three numbers, 7 is smaller than 9, and it is the largest within those three numbers. So we are just going to make a switch between 9 and 7. So that's essentially how we solve this problem. So runtime is going to be all of n, and the space-wise it is going to be all of 1. So let's do some quick stuff. So the coding part, so don't be too slow because there is some time limitation. And also think about the correctness of the code and also the readability of the code. So let's give it a shot. Alright, so if I would say, let's start with this one. So if array.length is smaller than 2, then we are just going to return array. Otherwise, what we are going to do is we will need to find the first breaking point. So it's array.length -1, I is larger than 0, and minus I. So if arr I is larger than, so I'm thinking if equal, I think equal it shouldn't work. So we should be finding like the real transition point. So if arr I -1 is larger than arr I, then we are going to say, okay, this is a transition point. So say transition pose as equal to -1. So transition pose is equal to this is I -1, and we are going to break. So if the transition point is equal to if the transition point is equal to -1, then you're going to return the original array because it is in decreasing order, so this is already the smallest one. Otherwise, what we are going to do is we will start from the transition point and find the largest one. So we are saying, okay, so going to start transition point +1. I is smaller than array.length, plus I. So here, what we are going to do is we are going to find the max. Let's say the max pose. So the max pose is defined as array transition position +1. Okay. So if or it should be like this. So transition +1. It is the index. So if array max pose is larger than, so if array pose I is larger than max trans max pose, then what we are going to do is we are going and also we need to have a condition, so we need to make sure that ARI, or maybe, so I think if ARI is larger or equal to the array transition pose, then you're going to simply break. Otherwise, it means that it is all smaller than transition position. So what we are going to do is we will need to. So I'm thinking if there are some equal numbers, which one should we use? Because it is a maximum, we are trying to find the maximum stuff. So if it is equal, I think we shouldn't really change that. Yeah, so if it is equal, the condition should be larger. It's not larger than equal. So it should be like the max pose is equal to I. Okay. And finally, what we are going to do, we are going to make a switch. Let's define a swap. I is equal, so pose 1 and pose 2, and also the array. Temp is equal to AR pose 1, pose 1 is equal to AR pose 2, and AR pose 2 is equal to temp. So we are going to make a swap between transition pose and also the max pose and also the array, and we are going to finally return the array. So that's mostly it, and after you're done with coding, please don't forget to do some testing. So for testing, we can just rely on this platform to help us at this moment. So let's see. This moment, I think it works. Let's see other test examples. Alright, seems like it works fine. Let's do a summation here. Alright, so it seems like everything works well. So like I said, first find the transition point and then find the maximum thing that comes after the transition point, and also we should make sure that it is smaller than what number is at the transition point, and also it should be the largest one within the rest of the suffix, and then make the switch. So that's it for this coding question. If you have any question about this solution or about whatever, feel free to leave some comments below. If you like this video, please help subscribe the channel. I'll see you next time. Thanks for watching.